Hello, we're doing page 487 in chapter 7, Adding and Subtracting Polynomials. I'm going to do the guided practice problems 1 through 6. These are just like the homework problems that you're going to be seeing, so watch these carefully and do the homework and the worksheet just like I'm doing this. All right? Number 1. Remember in the first video we talked about the shape of the exponent. The shape of the term. So this would be a square, and of course this would be a rectangle. That's a square, and that's a square, and that's a rectangle. I can add the squares if they're the same size. I can't add squares if they're different sizes. But these two happen to be the same size if I want to draw it out. Don't worry about the fact that it's an A. All I have here is A's. So I've got 7 of these squares, and I'm going to lose 10 of them. That means I'm going to end up owing 3 of those squares. The 9a doesn't change. So I just put 7 subtract 10 is negative 3, a to the second power plus 9a. And that's all there is for that one. Stop right there. This is not negative 3 plus 9 now, because these are two different shapes, so stop. You don't have to go any further. For this problem, I got x to the second power, so I've got 13 of the squares that are x by x. I've got 9 of the squares that are y by y, and I'm going to take away 6 of the squares that are x by x. The problem with this is that x and y probably represent different numbers, so these squares are different sizes. I can only add things together that are the same size. So these two are the same. 13 plus negative 6 is 7, so I get 7x squared. The 9y squared is something different, and I leave it alone. For problem number 3, I've got r to the 4th power, and again, it's hard to talk about the geometry of something to like higher than a cube, but we've got r to the 4th power, r to the 3rd power. These are not the same. I have r to the 4th power. These are not the same, but these two are. So 0.07, which makes me think of James Bond, but 0.07 plus 0.19 is going to be 0.26 r to the 4th power. And the 0.32 r to the 3rd power doesn't get affected. Those are different shapes. And I keep referring to them in terms of different shapes, but I should say they are not like terms. And hopefully by now you know what I mean by like terms. All right, problem number 4. Don't panic because of the fractions, guys. You can do this. What I do know is that this variable p to the 3rd power is the same as this. So these are like terms. I can add these together. The only thing I got to do is figure out what 1/4 plus 2/3 is. That's an elementary school skill, and I know that fractions make a lot of people uncomfortable, and I hope that this didn't happen, but I've seen before it's like, quick, grab a calculator, but you don't have to. If I'm going to add fractions, I have to have common denominators. I'm just going to do my work over here. 1/4 plus 2/3. So I'm going to add the 1/4 plus 2/3, and then it'll be that number times p to the 3rd power. I know I got the p to the 3rd power there. Looks like my common denominator is going to be 12. So 4 times 3 equals 12. 1 times 3 equals 3. 3 times 4 equals 12. 2 times 4 equals 8. Now that I have a common denominator, I can add them together. Denominator is still 12. 3 plus 8 equals 11. So this is 11/12 times p to the 3rd power. So now I've got multiple variables. I've got b to the 3rd times c, b to the 3rd times c, b to the 3rd times c. These are all the same. Whatever b to the 3rd times c is, these are all the same. So I've got 5 plus 1, which is 6. How do I know it's 1? Because of the hidden 1. Remember, you can always show the things that are in my class that are hidden. 5 plus 1 is 6, and 6 subtract 3 is 3. So this is 3 times b to the 3rd power times c, whatever that is. Finally, for problem number 6, I have m and I have constants. Here's another constant, a bunch of constants I should say, and here's another bunch of m's. So I'm going to put the m's together. Negative 8 plus 11 is the same as 11 subtract 8, which is 3. 3m. And I should probably put a trademark on that. I don't know, can you say 3m in Minnesota without getting in trouble? It's just 3 times m. That way I'll stay out of trouble. 5 subtract 16 is negative 11. And these two I cannot put together any further because they're not like terms. Alright, we'll see you in the next video.